Greetings. I am Joe Brown, and this is Millennial Physics, the 2017 edition. You can get more information if you visit www.joebrownscience.net. We're going to start with a pretend basis. We're going to pretend that there's a dust cloud around our solar system that prevents us from ever having seen a star. We can see the planets, we can see the asteroids, we can see the moons of the planets, we can see the sun, but we can't see any of the stars. And those of you who have read Millennial Physics from 2006 know why we are making this premise. The conclusion that I've drawn is that long ago we would have decided that the electromagnetic spectrum, everything from light up to ultraviolet and beyond and down to the lowest frequencies of electromagnetic spectra, require, and this is the word, require a medium, require a carrier wave. And why would we have concluded this? Because it all travels the same speed. I mean, that's the simplistic example. It travels the same speed. It does not matter how much power. It does not matter how much frequency. It does not matter anything. But in a vacuum, or what we call a vacuum, everything travels the same speed. And that is a no-brainer if you exclude the stars. Now I'm going to explain from the basis how this works. Because in the solar system we have a region of carrier wave. We have a region that carries electromagnetic spectra. It goes all the way to the edges, and it starts with the sun. Now, one of the things that has really tripped up humans is the premise that nothing travels faster than light. That is C. Nothing travels faster than the speed of light in a vacuum. Nothing. And that's just ridiculous. And I prove that, or at least I provide a proof for that in Millennial Physics. But what it gets down to is inside our sun, there is a region. And in that region, time does not exist. It's not complex. It's just that everything's moving faster than the speed of light within that region. Now, that specifically says that if you have a point from anywhere out here, and you're looking in there, that everything that you're going to observe is traveling faster than light. There, of course, must be a place on the outer surface of this region where things start to slow down, where things start to integrate with our universe. Because in here, time does not exist as you understand it. Time is not a concept in there, because everything's moving faster than time. And I will get into why we know this is true. But for now, we're just going to explain that everything in there is moving faster than light. So you can't really define a particle the way physics defines a particle. You can't define movement the way that physics defines movement, or the way that movement is used and applied in physics, because everything in there is working with a different set of rules. The humor here is that we have been doing our best as a race, as a species, to try to explain how everything works, and we've completely ignored the fact that everything inside our sun moves faster than the speed of light. Now, at this border, at this boundary, there's a transition. And within the last 40 years, we have begun to understand what's called a fractal. And a fractal is an equation. It is a family of equations. But what it basically says is that as you make the venue, as you make the space in which you define a fractal smaller, the number of features diminishes within that space. The number of features on this surface diminishes as you shrink the space, but it also states that it never goes to 1. It never goes to a linear feature. No matter how closely and finely you divide that space, you still have complex features. And they're all related as they get larger and larger. So what we're going to show you is that by definition, the innermost surface of what we call the event horizon of the sun, the innermost surface is perfectly flat because it is traveling faster than the speed of light. It is beyond the speed of light. Everything moving inside that is moving faster than light, but as soon as it begins to transcend this space, it begins to divide into geometry. Geometry between this space and our universe. And as it travels farther out, as you travel farther out into this boundary, this membrane, whatever you want to call it, as you travel farther away from the sun, the membrane becomes more solid and the fractals become more general. And as you emerge on the other side of this event horizon, you have definitive fractals that are definable in our universe. And that's the whole definition. That is the definition of this boundary, is that on this side you have no relationship whatsoever with what we currently call the universe. On this side, everything coincides and is understandable within the mathematics and modeling of our universe. So what we have here is everything inside this membrane is not defined. But what it does is it generates this boundary. And this boundary has a result, has an impact on the area around it. And the area around it is our solar system. And again, that's all we can see. We can only see the solar system because the stars don't appear and they've never been seen. So it is the full range of what we understand. And what happens here is that the effect of this spreads outwards. And how do we know this? Well, it's real simple. We have made amazing photography occur using the electromagnetic spectrum on stars and galaxies that are so far distant that we can't, as humans, grasp how far that distance is. We talk about how far across the whole universe we travel and can travel with the vision that we see. But we can't get a good photography process that can show us Pluto from the Earth. Now we've gone, and if this were the sun and this is the Earth traveling around the sun, we've taken photographs from here and from here of stars, trying to get a little bit three-dimensional. But when we try that with Pluto, it's worthless. And the reason for that is simple. Like every other radiational source, as this boundary expands in real time, all the time, as it expands out into the solar system, its effect diminishes. And how do we know that for a fact? We know that Because right here is the Earth, and right here is Mercury. Right there's Mercury, right there's the Earth. And a number of years ago, we sent a probe to Mercury. And Mercury is much closer to the Sun. And they did a test that I've really got to give them credit for having thought up, having done this. But they did a test of chemistry. And what they found is they could graph exactly, precisely, the rates of reaction that that experiment would generate on Earth. They measured it and exhaustively quantified what that exact experiment would do on Earth. And then they did the same experiment near Mercury. And guess what? It's different. In other words, the rate of reaction here, close to the Sun, is different than it is on Earth, of chemistry. Now, we, until that point, had presumed that chemistry was universal. You would go somewhere, it didn't matter where you went, and that chemistry would be the same, but all of a sudden, bam, no, it's not, and it's proven not to be. It gets a little cloudy because Mercury is smaller, and that might be the reason. Earth is bigger, Earth is stronger, Earth's tougher. Oh, okay, Mercury's smaller. But here's the thing. It doesn't matter. Because what we know for a fact is that if what I'm saying is true, then the Earth's effect on all things is going to be different than it is on Mercury. Because the factors that are Earth, the factors that make our Earth properties what they are, our chemistry, our atomics, are set by how big and how much mass the Earth has, and Mercury has a much smaller mass. So what we can deduce is that as this broadcast travels out from the Sun, out from this event horizon, it connects with Mercury, Venus, Earth, Mars, all the planets, all the asteroids, and it provides an effect on each piece of mass. And we know all about that. We do. We know everything. It's exhaustive what we know about how mass works in our sun, in the purveyance of our sun, within the boundary of this field created by the sun. You have the gas giants out here. You've got Earth in here, you've got gas giants out there, and then you've got the really cold planets. But we know that Neptune is cloudy. We know that Pluto's a rock. So there is a lot to learn here about what goes on farther out, but we know for a fact that it's very difficult to photograph Pluto until you get close to it, like we just did. And we found that it is very well resolved, even though the best pictures from Earth, no matter how hard we tried, look like mashed potatoes, look like smashed, a gooey blob of snow, a dirty snowball. That's the best picture we could get. The best example of why this is true is that mathematically we have all but proven that there's another planet out there that is about the size of the Earth, and we can't find it. Why can't we find it? Because it exists at the perimeter of this boundary. It exists at a point beyond which our instruments can use the electromagnetics to find it. We're using electromagnetics because we've already found it with gravity. And it's out there. And it's circling, it's hanging out with it. We don't know where it is, we can't find it. And if there's anything at all that demonstrates that I'm speaking what really is, it's Persephone, or whatever you want to call that planet that we're going to find pretty soon, I presume. the sun generates a field that encompasses our entire universe because we can't see beyond the solar system. And the interesting part is that it sets rates of reaction. It resets the rates of motion. Electromagnetics only travels at one speed in this field from the sun. And folks, that's time. The sun defines what time is. Time is not universal. Time is set by this guy right here. And it's, again, if we didn't have the stars to look at, it would be a no-brainer. It would be an obvious thing. But we have them to look at, so it has not up until now been obvious because there's not been enough evidence. Now there is. So we have an entire system of physics that is set up based on the sun. So the thing is that everybody talks about hydrogen defining the sun and how the sun works. No. The sun defines how hydrogen works, how carbon works, oxygen, plutonium. And it's as simple as that. It's not complex. All of our physics still works. The only difference is that it works exactly, precisely, only within our solar system. So if you were to go to another solar system, the sun, by definition, has a different time signature. So all of the physics that is for that solar system will be slightly different. There will still be hydrogen. There will still be hydrogen combining with other elements. The difference is that the periodic chart might have things shifted around a little bit. Masses, and of course rates of reaction will be different. And it may be that there are some, well, there will be some solar systems where fluorine is not inert. It's not a noble gas. Not fluorine, yeah. Neon, rather. Fluorine might become a noble gas. Oxygen may not have any interest at all in hydrogen. But carbon and hydrogen might do bad things. So it gets down to being able to understand and accept that our vision of physics is still as wonderful as it's always been, but it's limited precisely to our solar system. Now, that may be hard for you to believe, and I understand that. But I want you to see something, and we're going to go there next. Here's the Earth. You've been there. Here is a star. And we can look at that. Well, by the way, we've taken the dust cloud away now. The dust cloud is gone. We've taken the dust cloud, and now we can see stars. And we see a star. It's looking up in the night sky and seeing a star. And it doesn't matter. It could be any star. But in this particular condition, there's another star that, when you look into the night sky, is right next to it. So when you're looking at them, they're right next to each other. Now, that's fine. And we have billions and trillions of examples of this. But there's a problem. And that is that no matter where these two stars appear in the cosmos, one of them is going to be closer than the other. And that's a real problem for electromagnetics. And the reason for that is a little bit of a departure. In 2006, I presented this model. And unbeknownst to me, or at least I wasn't really paying attention, I do remember hearing about a supernova. But scientists detected a supernova, and coincidentally, it happened to be viewed from the Earth at the time of the going supernova, when it was right at the edge surface of Pluto. Or no, sorry, I misspoke. On the edge surface of Jupiter. Big planet, Jupiter. You look beyond Jupiter, just over the horizon of Jupiter with the telescopes, and you saw this supernova. And because they caught it as early as they did, and because they were ready, the amount of science that was poured into this observation was remarkable. And the best part about it was that it was complete. It was considered to be the best astronomical science of any supernova that had ever occurred, and basically any changing astronomical event. And they continued to crunch the numbers and do the calculations up until about 2011, when they finally started publishing the really in-depth data. And what they found was considered, and is still considered, one of the finest collections of group scientific process that's ever been. In other words, I'm going to call this really good science. What they found is that Jupiter was capable of bending that signal, bending the gravitational or the magnetic. No one can ever say for absolute certain, but something about Jupiter had the capacity to bend the light that was coming from that supernova, bend the electromagnetic spectrum. What I want you to see at this moment is that our best science says that Jupiter bent the light, bent the electromagnetic information from that supernova around itself. It came past the globe of Jupiter and got bent. Now, back to our pair of stars. The light from this distant star has to come right past, must go right past the near star. Sorry. And in some cases, the stars are virtually in time passing each other, just going by each other as we view them. And if our best science is true, then by the definition of how things work in physics, that signal has to be bent. And the closer they get to each other, the closer this gets to this path, the more it is bent. There is no way around that. And that does not happen. And here's the quintessential point. In the billions and billions of stars that we view, it never happens. Never in the slightest bit. We look at the electromagnetic spectrum of that far star, and as this near star passes by it, it never changes. As we look at that far star, we look at the spectrum of that star, which is a unique signature for each star, and it never changes. We can look at galaxies and see the stars, measure the stars, and they don't change. That should be, well, okay. If for the presumption that the emissions that come from that far star to Earth for us to view is electromagnetic, is by the best science we know, and by the best science that we have been able to create, the word is impossible. And I'm going to repeat that. Impossible. It cannot be. Now, I knew this, like I said, in 2006 I published it. I knew it for 20 years before that. But it's very hard to convince people that what they're looking at in the sky is not light. It did not arrive in our solar system as light. the emissions come from that far star and all the stars and come into the realm of our sun. And our sun creates a huge field the size of our solar system. And that solar system size region has the ability to, and I'm going to use the word that they use in broadcasting, demodulate the signal from that far star. I cannot state completely how that works. I cannot, but I can show you what I think. Inside the sun, we have this region that we know is traveling faster than the speed of light. No matter how it works, no matter what goes on, it's got to have some kind of, we're going to call it a center. It's got to have a point that represents this whole region. And that point is in motion, and it's in motion faster than the speed of light. But what I think happens is that the motion of this star is in direct connection with the motion of that star, and that falls into Newton's universal law of gravitation, that there is a different condition that exists outside of what we call physics. But just as this exists outside that, and the point is that these 2 points, the centers, are in constant motion in relationship to each other. And that's a no-brainer. I mean, they're going to be. There's nothing that you can say about that. I mean, you can argue whether this is all moving faster than light or not, but you cannot argue that whatever you call the center of the sun is in constant motion in relation to that one. And that constant motion involves a constant change in distance from each other. And we, in this model of mine, know that that motion moves much faster than the speed of light as far as its rate of movement and detection. And the whole system is moving faster than anything that we can create. And what happens is that when that motion gets involved with the center of our solar system, it has to travel through the region that is defined by the sun's radiation. It is demodulated, and it is demodulated at any point, every point, because it's a carrier wave, if you will. It's what we call in radio a carrier wave, and it is demodulated as it travels through, which makes perfect sense, because EM travels at a specific light. It extracts from this raw signal everything that is working in the electromagnetic spectrum. So we can see the whole spectrum of that star, no matter how far away it is. The interesting part is that the only thing that would upset this whole system if you had a binary star, and guess what? We're discovering that binary stars, stars that have two different stars that are related to each other and have a strong interaction, they upset our ability to look at these, because again, they're sharing a gravitational system. Black holes, they're going so fast that not too much shows up. We get residual outside a black hole, but a black hole is just a hugely dense star. So, we know the facts. The sun is setting, so I've got to wrap up here. The speed of light is set specifically for our solar system. Every other solar system will have a slightly different speed of light. rates of reaction for every star, no matter what part of the electromagnetic spectrum you want to get into, no matter what chemistry, thermonuclear, whatever, will be slightly different. There will still be hydrogen atoms and oxygen atoms with all of the elements remaining, but their properties as individual elements will be slightly different. And so that's the unified theory. I mean, it really is. It defines time, which we've always been wanting to do. It defines our realm in the universe. It defines all of the major aspects of physics and chemistry and all the physical sciences. And the best part about it is that there is virtually no information that we have received experimentally that disagrees. It all fits in. And for the next 4 or 5 years, there is going to be a scramble to adjust everything to this model, because what's going to happen is that the people who adjust best are going to find out one or two things that they don't know. You have a star, and you have the center of our sun. The electromagnetic spectrum is manipulated within the solar system. But there are higher frequencies that can do work. This is a propulsion system. And the nice part about it is that somewhere in the 1980s, I forget what year, I can find out, but somewhere in the 1980s, I gave the United States Air Force the design of the system that would detect these systems. Like I said, I did this a long time ago. And we will be able to use that in the solar system. That's the important one. We will be able to almost immediately use this propulsion system within the solar system. And what we're going to use it first for is that we're going to align a craft here between them, and we're going to use it to accelerate out from the sun and go out a specific distance and then slowly arc back in. And then we'll be able to figure out how to get it to come back. It won't be as powerful, but we'll be able to figure out how to get it to come back. And eventually, we're going to be able to traverse that distance using this, because if the universe is the same as our principles on Earth, then that carrier system that travels from here to there is moving a lot faster than electromagnetics. It's a lot faster than the speed of light, and it will make everything in this star moving in slow motion. So if we can tap into 1/10 of it, we can get to Pluto in a couple of days. And that's how it works. That's how it's going to work. The other part is that if I'm going to use any form of communications to talk to people in the universe, I'm not going to use electromagnetics. And you can see now that electromagnetics don't go out that far. And how do we know this? We know this because if you look up in the night sky, it's black. Now think about it. There is nothing more telling that the electromagnetics don't continue on from beyond the solar system than the fact that the night sky is black. We're not getting that radiation in. We're getting residual radiation. We're getting non-specific radiation, which also explains and validates the system that I described. We knew this from the 1960s when Bell Labs built those huge acoustic listening systems and pointed them into the sky and found out there's noise everywhere. It's incoherent, but the point is, if you're trying to talk from one solar system to another, you can't use electromagnetics. So all of their antennas are basically looking at the noise of suns, which is cool. But what I showed the Air Force in the 1980s will find communication. So, that's pretty much the presentation for 2017. The fact that it's 2018 now basically expresses how my life is going right now. It's I'm behind on everything. I did this once before, and the camera didn't work. I did it in 2017. The camera didn't work, but we're just now moving into 2018, and I expect to have to do something like this again pretty soon. If you like this presentation, if you think you got something from this presentation, if you think this had any merit at all, please consider going to Amazon.com and looking for the electronic book, the ebook, The Boson Maru, which I wrote a number of years ago. It is science fiction. It's well reviewed by the few reviews that have been posted. And see if you can help me with my retirement. I'm a capitalist, so this is my request that you honor me by contributing a couple of bucks. It's $4 for the book, US. And give a bunch to your friends if you think it was super. And I really appreciate this. Thank you very much for listening. One of the most incredible demonstrations of why this is all working is that modern astronomy is using galaxies to pretend they are, to use them as pseudo lenses. And there is no grasp of how ridiculous that is if you're looking at electromagnetics. I mean, we can look at galaxies and we can see into them, which, if it were electromagnetic, would be impossible in the first place. It would be one glob. But we can look and use, supposedly, they pretend they have success with using the field that is that galaxy to act as a magnifying lens to look beyond. Look within it, look through it, and look beyond to see if there's anything beyond. And they claim they have results. Well, again, if this were all electromagnetic, that would be impossible. But if it's gravitation, if it's gravity that is talking back and forth between our galaxy and between their galaxy and our sun, then it's completely plausible and works. There's something else. There is a premise that there is a huge, and the word is huge, black hole in the center of our galaxy. And that's ridiculous. For one simple reason, if there were a huge black hole, there'd be no galaxy. It would be all sucked in. But what's happening there is that by the nature of how galaxies are, time is different there. Time is moving faster there. The entire set of stars in that region, by their proximity, are more connected with each other in a manner that accelerates time between them compared to us. We're out in the middle of the arms. There's stars that are farther out, and there's stars that are closer. And the ones that are very, very well packed into the center all act as an accelerator, essentially, that means that they're oscillating as a group faster. So basically, it's not that there's a huge black hole there, it's just that the time frame of the emissions out of that region are so much faster that they don't coincide with our time. Now, it may be that we will be able to adjust our systems, our instruments eventually to see into there. I don't know. But that is one of the crazy things that's going on that people don't understand. They use the premise that since they can't see in there, that it's got to be a big, huge black hole. No. There may be a lot of black holes in there. There might be some pretty good sized ones. But as far as there being one big black hole in the center of the galaxy, no. The thing is that one of the dynamic things that goes on is that, hold on, get my rusty pencil. This is the Earth. The Earth has a region in the center. And Millennial Physics Online, the website, it goes into great detail here. But basically, when there's an earthquake here in one section of the world, the information travels out, but there is a cone. And this region here never sees the vibration. And the reason it doesn't see it, everybody presumed, is because the center of the Earth is solid. No, it's not solid. Not a chance. It's not possible for it to be solid. But what's going on has to do with the center of the Earth, the actual point of the center of the Earth. And the point that is the center of the Earth is in constant motion. And what happens is that by the nature of how high the frequencies are in that region, it is not possible for seismic waves, as low as they are, to go through without being completely damped. Well, it's the same with the galaxy. It's not possible for electromagnetics to come out in the same way they do out here because it's too busy. I have some really bad news. It's not the snow. The snow means it's another day. The concept that we have of photons is almost completely in error. Somehow the electromagnetic spectrum generates no photons anywhere else, but when it gets into the very small region of optical light, visual light, it suddenly produces photons. No, it doesn't. It's just that we first observed the ability of electromagnetics to do work with light. We used that principle to presume that it had to be physical particles that did the work, and it really isn't. We know that this whole event that we're watching as humans resides inside the sun's field of gravitational energy that it's producing. We know this is such a high frequency that we don't even measure it. We can't measure it. And when the optical electromagnetic media travel through this, every so often they reach a situation where they undergo a combination, and it's called interferometry, but basically they collide together with other related radiation and you get interference. You get, in some situations, an event that takes place in a very specific volume of space, and it essentially is a rogue wave. If you've ever heard of the term rogue wave in the ocean, where at some coincidental moment, a whole collection of waves collide in one particular spot, And rather than creating a trough of no energy, it creates a trough of huge energy. And what happens is that a bubble is created, and I'm using a metaphor here, but a bubble is created that drops itself out of the electromagnetic spectrum and down into the mechanical spectrum. And at that moment, it allows itself to do work, but that photon is gone in a moment. It's gone almost instantly. And if the light reflects off of a surface, you get that interferometry between the incoming and the outgoing. If you have a standing wave that's on the surface that's related to the color of the surface and the texture of the surface, you get interferometry. And so the whole point of it is that the explanation for photons doing work, for X-rays doing work, for just any electromagnetic media spectrum event doing work is all the same. Now, there might be some magical harmonics basis for light to have a slight advantage over some of the other frequency ranges. But it doesn't necessarily mean that it's any different. We see light because it works with our eyes. We study light more than anything else because we can see it. So it just gets down to understanding that the concept of photon is a very human one because it's what we see and what we've always seen historically, but in reality it's just an excuse to call for mechanical work being done by light. We don't need that anymore. We haven't needed it for a long time. But we still talk about photons because a lot of our science is based on the mathematics of photons. Well, what it's really based upon is the mathematics of envelopes of space in which the subharmonics of interfering waves produces a frequency of item that is so low that it drops out of the electromagnetic and allows work to be performed. And that's really all there is to it.